So let's start with something and see if you can remember from yesterday. I'm going to give you one compound, and then I'm going to tell you what I want you to do with it. Let's do okay. So the first thing I want you to do with that is to find its molar mass. Now, raise your hand if you remember without flipping back into your notes. Do you remember how to find molar mass? Yeah? Let's try. Ty, are you okay? You look like you don't feel well. Okay. Okay, so let's figure out the molar mass. Get your periodic table, calculate it. Oh, you might want your calculator too. It might help. Okay, how many strontium are there? How many SR? Jackson, how many? Three. How many arsenic are there, Jacob? Two. And Evan, how many oxygen? 8. So let's check our individual molar masses. I would use strontium at 87.6. Is that what you used? I would use arsenic at 74.9 and oxygen 16.0. Yes? Okay. When you punch these in, Tayden, what'd you get for strontium for your total?
I added more.
262.8. Did anybody write that down? Is that right? Okay, so I'm going to tell you now, the next one we do, I want you to get in the practice of writing it down because we're going to use it for something else. All right, what'd you get for, Brooke, what'd you get for arsenic? 149.8. Okay. Kyle, what'd you get for oxygen?
I would go up with 128.
One what?
120.
Okay. And all of these, of course, would be grams. Then when you added them all together, Tayden, since you did it all together, what'd you get?
540.6.
540.6 grams per mole. And I would also have to write SR3, ASO4 twice if I wanted full credit. It's a really good idea. If you're doing this on a quiz, go ahead and box it off. But it's a really good idea to keep track of them individually as well. Now, I could also say to you about this particular compound, how many particles are present, or how many atoms. Sometimes it's worded like that. How would you go about figuring that out, do you think? If I just want to know the total number of atoms in that formula, or the total number of particles in that formula. Have you ever done that before? Okay, so it's fairly simple. This is before we get to Avogadro's number, which we talked a little bit about yesterday. I just go through and I add them up. So I've got 3 plus 2, which is 5, plus 8 would be 13 particles. Again, I just looked at each individual part and added them up. Does that make sense? Okay, so the other thing I wanted to show you today is a formula that looks a little bit different than what we've been working with. And we use them a lot in lab. It's called a hydrated chemical. Now, think about that for a minute. If it's called a hydrated chemical, what do you think it has in it? What do you drink if you want to get hydrated? Well, what is the best thing to drink if you want to get hydrated? Adam? Yeah, water. So I don't know who said it. Somebody said it. So this hydrated means with water. And when we have a chemical formula that's hydrated, we have to show that. So I would write that this way. Let me think of one really quick. So the formula will look something like that, and that would read iron chloride with 6-part water. A lot of the chemicals that I buy to use for Chem 2, like that I make the solutions with that we use for our labs, are hydrated chemicals. So I have to know how to work with them. You have to know what do you do with that when you calculate molar mass. So when I want to find the molar mass of a substance like this, I don't do anything differently. I still have to include every atom that's part of the formula. So what do you think I do with this number out front? What do you do with that in math? Jacob? Yeah, you carry it through, right? You multiply through by the coefficient. If you have, usually you have parentheses in math though. We don't put parentheses around this. So I have to keep that in mind when I look at my particles. So I still list them out, Fe, Cl, H, and O, but I have to keep it in mind when I go through to calculate my mass. So iron I have 1, chlorine I have 3, Marty, how many hydrogen do I have? 12. And I have how many oxygen? Lexi? 6. And then I just go through and I fill in my molar masses. So I have to go back to my periodic table and I have to find them. So everybody find iron. Ty, what'd you get for iron? 55.9? Okay. Evan, what'd you get for chlorine?
35.5.
Yep. And you'll get to the point where you use hydrogen and oxygen enough, you'll memorize them. So go through and find your part of each. When you have a total, stand up. Okay, find somebody to check with. Y'all agree with what I have written up front? That's what I heard you say. -2. What did you forget to say? Grams per mole of iron chloride with 6 parts water. I wouldn't expect you to give me the words, but I would expect to, whoops, I'm pointing to my screen. I would expect to see all this, so I should have grams per mole FeCl3.6H2O. Okay? All right, now I'm going to show you the new thing. Well, that was new, but one more thing. So, as we move into lab tomorrow, the first part of lab is practice with like chemicals that you have to read the labels, and you have to find what they are, and then you have to find the molar mass. Then you're going to find what's called the percent composition for each, and then it moves it into the next phase of lab. So, we need to talk about percent composition of chemical compounds. And what this is a way to find each part of the whole, or a way to find what percent each chemical is of the whole. So it's a way to find what percent each chemical element is of the whole. And I'm going to work through a whole one, even though we've already done the first part of it a couple of times now. So let me think of a chemical here. Okay. So there's my chemical, and the first thing you have to do is find the molar mass. So I want everybody to go through individually and find the molar mass. When you have each element's part, stand up.
I'm standing up.
All right. When you have each part stand up. What? Nope, just each part, each individual part. We need to check those first. Need water?
What are you guys doing in class tomorrow? Oh, really?
Yeah. I mean, it's the beginning of the lab. We won't be to the good part yet, but,
That's okay.
okay,
So Pioneer Electric's gonna be on campus tomorrow. They're gonna look at all the lights.
okay.
They're gonna give us a check for like $25,000. Last year when they did it, we went down to the music room and bunch of the kids had musical instruments, so they could
Yeah,
put in their
yeah.
newsletter.
Oh, cool. So they'll have their goggles and aprons and
That's,
everything.
I was trying to
That
think.
worked out
I was trying
perfectly.
to think of
Yeah.
a creative.
Yeah,
And
that's
then I
great.
usually write a little article, it was LED lights or music to Miami East Ears,
Okay,
blah, blah, blah.
perfect.
So I'll have to find some sort of
Yes,
catchy
there you go.
science.
Yeah, that'll work.
Okay.
And they're coming during this period?
1:30.
Perfect.
They'll bring a big oversized check, and I thought, well, if we did a science lab with their goggles and stuff, I'll
Okay.
write a nice little article.
Perfect.
Cool,
Yes.
thank you.
So you will keep your goggles on the whole time tomorrow, people know. All right,
you.
so, yeah, thank you. Let's talk about your numbers. And let me unfreeze this. So first, let me ask you this. The way I have it written, did you notice that you have n in two places? Did anybody combine those? Yeah, and that's perfectly fine. Doesn't matter to me if you did or did not. Caitlin, what'd you have for a total on your n? Yeah, say it loud. 140.0 grams? Yeah, and I'm going to get rid of this one because we won't have to write it down. Brooke, oh, that's pretty easy. I don't even need to ask Brooke. There was only one of those. Iron, there was only one, so that should have been easy enough. Carbon, what was your total, Kyle? That has a recurring theme today, Kyle. 72? All right, do we all agree on all of those? Yes? Did anybody total it up? All right, oh, what'd you get?
No, I didn't go.
Oh, no, she didn't total up. Marty, what'd you get? 283.9 grams. Total it and see if he's right. I was going to, but I got interrupted. We good? All right, so that's the first thing we have to do. And you'll see why I'm having you put them out to the side like this so they're quick to go back and find. So now I'm going to say find the percent of each element type present. So this would be like step 2. And I'm going to move this and we'll carry it over to the next page. So I'm going to take each one, and this is the way I want to see it so it's easy to follow. I want N, H, Fe, and C. And then we're going to carry over their masses, 140 grams, 16 grams, 55.9 grams, and 72.0 grams. So we take the part divided by the whole times 100 to get our percent. So my whole, I have to look back and find it, was 283.9 grams. And then I'm going to multiply each by 100 to get my percent. So go through and do that. And let's see what percents you get. When you've got it, stand up. Are you done?
Yeah, I'll just reach out.
Okay. Ty, what'd you get for nitrogen? 49.3?
31.
31?
49.3.
Sorry.
No,
Okay, that's what I thought you said to begin with. Jacob, what'd you get for hydrogen?
5.6.
5.6%. Kyle, what'd you get for iron? 19.7 green or percent. And Jackson, what'd you get for carbon? 25.4%. Okay, they seem reasonable. How could I check and know if I'm right? Caden? Add them all up. If I add them all up, what should they be pretty darn close to? 100, because I want 100%. Yes.
So do you want us to run this to the 10?
Yes, that's a good rule to follow, yeah. And I would, when you check, as long as you're like somewhere between 99.8 and about 100.2, you're gonna be in good range with the way that we round. So add those up and see, do we check? Do we check? You already did it? Perfect. Okay. That's where I'm stopping.